Hi everyone! Today I would like to discuss with you the following situation. For example, you are preparing for the interview and there are two cases. Maybe you will conduct an interview or maybe you will participate as an interviewee in this process. In both of the situations, usually we prepare using Google or something else, for example, to search some interview questions and answers. And let's remember maybe one of the common questions is how the put method of HashMap works. And in the most of cases, the answers from Google can sound like there is an array with, for example, if you put some object, the hash code is going to be calculated, and then according to this hash code, the position in the array will be selected, and according to this position, there is some root node for the linked unidirectional linked list, and then if the position is the same, then hash code and equals will be calculated, and this new entry will be added as a next node, as a next element in this unidirectional list. But let's take a look on the real code, because I'm not sure that it is the right explanation. Okay, here I have Java version 11. If I take a look on the method put, here we can see the hash method, and here you can see that it is strange. Okay, the first part is simple because we know that we can use a null object, we can use null as a key in HashMap. Okay, and in this case we will return 0 integer. And then there is an interesting part of code. You can Google how it works. It is bit operations, and the main idea that change your hash code to avoid some collisions. Here, because next we will need to consider the place in the array according to the size of this array. Yes. And then it is kind of hashing of your hash code to avoid just duplication. Okay, let's move on. Then we go here in put vol method, and then the first thing which we need to get this array with our nodes. Let's take a look on the internal implementation of node. We have 4 elements, hash, which we calculated before, key, value, and next. According to the implementation, we can recognize one directional linked list. Okay, let's move on. Next, we are going to check table equal null, or the length of the tab table equals 0. Then we invoke this resize method and get length. Okay, we have two purposes of this: to initialize this tab, this array, and to get a length, assign it to this variable. Okay, let's take a look to resize method. Here, as you can see, we have kind of complex code. Not actually, it is not so complex, but it is complex because of lots of conditions and so on. The main idea which you should understand that we use threshold and also, all threshold and alt cap, all capacity. Length, and then if we don't have alt capacity before, we use these values. And as you remember, probably you remember that map you can put some arguments, for example, like here, initial capacity. But by default, the initial capacity equals 16. And the interesting thing, we have lots of constants, but we never use it here. we use just inline magic numbers everywhere, like you see here. That's why for me it is quite, I don't know, surprising. Probably there is some reason to do this, maybe optimization and so on, but anyway, let's move on. Okay, as a result we have here array and length. Let's move on. At the next step we are going to find our, or assign, or put our root node to the array, or do something else. Let's take a look. Firstly, you see we are trying to get the position of this node, root node, and we, as you understand, we don't use mod. For example, we don't use something like this to calculate it, because if this will be something like this, it will, the result will be -1. We don't need this. We want to have a positive integer here. That's why we use this operator. Okay, then if we get it null, then we don't, it means that we don't have any element in the array with this position which we calculated right now, and then we just created new node and assign it to this, and we exit from this if condition here. Then we added this mod, and you can find out that we increase it only when we assign some new element in the tab, not added to this linked list, but kind of linked list, yes. But only when we add new element to empty space in array, not empty, but new index in array. Okay, and you see if this mod this size more than mod count, it is for different purpose. If you remember, we can get concurrent modification exception, and usually if we try to iterate through elements in this map and try to remove or add something, and this mod count will be increased, and then in the next iteration, if it changed, you will get concurrent modification exception here. Okay, then if size more than threshold, you can set it manually, or it is 75% by default. We will resize, and then next we will go to this method, but we don't use it in HashMap, and we use it in linked HashMap implementation, but we will not take a look on this. It is not the topic for today. Yes. Okay. Where we are? Put all, and then return. Now, because it is, we visited only this part, and here we just add new element. We are not going to return something called because we have no old element. Yeah, let's take a look what we are going to have here. Here we try to, here it means that using this operation we got this object P. You see, it is difficult to read this code because they use short names like C-style names, and that's why I would say it is really important to have meaningful names to read the code easily. Okay, let's move on. Here we get a hash of the existed element, node, and compare it with our new element hash if it is equals, and if we are trying to compare just reference, if reference are equals, means that it is just optimization. Or if key is not null and we use equals method, if they are equals, then we go here and we just say, we can say that, okay, it is the same key, and then we can use it. We can use this node to our in further. Okay, for example, if we get, let's just jump in the bottom. For example, if we got this node, then we will return later to this part. Okay, jump here, and if this node not equal null, if we found it, we get alt value. If it is, we use this parameter. If we need to edit, if only if absent and so on, we don't care for now. And we assign this, and we return alt value, and we again node access. It is going to be used only in linked list in the standard library. But by the way, you can use these methods in your implementation if you decide to, but no, it is not public. Okay, let's move on. Let's move on. The next condition, instance of HashMap. It is interesting thing because usually if you read some answer for the question, almost every answer contains the information that we have linked list inside of the map, but there is almost nothing about any tree structure. Let's skip it right now and we will return it later. Okay, if we go here, if it is not instance of tree map, then we set this bin count equals 0, and then we will start iterating here. Okay, we will try to take next. If it equals null, just let's skip it for now. If let's imagine that it is not null. Here we apply the same check like here, as I described before, and we already get this E element, and if they're equal, then we return and do the thing which we already discussed. Okay, and if we received, we go through all of elements of this linked list and we didn't find anything, and also if this bin count 7 or more, then we will go to this method. And here, as you can see, this and this code, I'm going to go through all of this logic, but just simply here we will change the structure. We will change our linked list to B tree, to it calls red black tree, search tree, something like this. Yes, and also I heard from other developers that when we reach a huge amount of these elements in linked list, only after that we will create this tree structure. But you can see just 7 times, 8 times actually, when we get here, and then we will change the structure of our linked list to tree, and then break. And then, as I discussed before, we can go here if it is already tree structure, and we will invoke this putTree value method, and we will add it. That's it. I think I described. You see how much time it can take only to discuss only one simple method of HashMap. But Java has a lot of interesting data structures, algorithms which we can discuss, and so on. And if you have any question or suggestion to discuss in further, please put your comment in the comment sections, and subscribe, press like button. Thank you for your attention. See you later. Bye bye.